Okay, first of all, I want you to notice all these functions over here: cofunction, even, odd, sum and difference, and double angle. You will never have to memorize these, and here I will always give them to you if you use them. You will be using them in higher maths and definitely in college. Okay, so these examples on the right side go along with what we're doing in class. So what I'm going to do over here is this cosine of 75. I'm going to use the sum and difference formulas. And I cannot draw a triangle. Like, I don't know if I draw 75. I cannot find the values for 75, and I can't find that exact value. So I'm going to replace cosine of 75 with one of these sum and difference formulas so that I can figure out the values of cosine of 75. So cosine of 75, first of all, I want you to notice this. This right here is different from what you have, so I want you to flip it. It is just a negative over a positive. And also this one right here on tangent, I want you to flip that one as well. Okay, so it looks like we're using the cosine formula. So since these are equivalent, this right here is equivalent to this right here, I'm going to replace them. So cosine of 75 is equal to a cosine of, and it doesn't matter the variables, a u plus or minus a v. So I'm going to say cosine of some variable, u, plus or minus a v. Okay, so what I want you to think about is we know a 30-degree triangle, we know a 60-degree triangle, and we know a 45-degree triangle. So I'm going to try to replace this u and this v with one of these three or two of these three numbers here in order to get 75. Okay, I'm going to replace this with cosine of 30 degrees and add that to cosine of 45 degrees. Because I know that if I add these two numbers together, I get 75. Now I'm going to write out this ugly thing right here and replace every u with a 30 and every v with a 45. Okay, so looking over here, this says cosine of 30 degrees times cosine of 45. Then it says, because I'm using a plus sign on top, I'm going to use a subtraction sign. So plus goes with minus and minus goes with plus. So I'm going to say minus. Now I'm going to use sine and 30 degrees times sine of 45. Okay, so we know what a 30-degree triangle and a 45-degree triangle look like. So let's draw those two triangles. I'm going to bring those off to the side and draw a 45-degree triangle. That is a 1, 1, and a square root 2, and a 30-degree triangle. 30-degree triangles are a 1, 2, and a root 3. Okay, so cosine of 30 degrees, cosine is adjacent over hypotenuse. So adjacent over hypotenuse is going to be root 3 over 2. And then go to the 45-degree triangle and find cosine. So that's going to be times 1 over square root 2. Okay, so I multiplied those two. Now let's do the same thing with sine. Sine from your 30-degree triangle is going to be 1 over 2 times sine from your 45-degree triangle is also going to be 1 over square root 2. Okay, we just need to simplify inside the parentheses now. When you simplify these, you don't have to find a common denominator, just go straight across. So this is going to be square root 3 over 2 square roots of 2 minus 1 over 2 square roots of 2. And I'm okay if you leave it like that. You can simplify more, but at this point, if you can get this step, I'll be happy. Okay, let's look at number 2. Okay, this one's actually a lot easier. Sine of 100, again, we cannot draw sine of 100 and get the values. Whoops, that's not even 100. 100 is over here. 80 degrees. I don't know all the values for 80 degrees. So let's do it backwards and see if we can make it easier. So if I have a sine times cosine plus a cosine times sine, what could this be equivalent to? If I look over here, a sine cosine plus a cosine sine is like this one. Okay, so because I couldn't draw the triangle and find the values, let's work backwards and let's make it easier. So like your identities, if you can do something and make it easier or equivalent, then replace it. So this is like sine of 100 plus 20. So I'm making equivalent expression, and this can be simplified to sine of 120 degrees. Okay, we don't know this exactly, but I think it's going to be better than that one. So let's graph 120 degrees and see if it's a little bit better. If this is 120, then that means this is 60. And we do know 60s. So this is going to be 1, actually negative 1. This is going to be 2, and this is going to be root 3. So sine from this triangle is going to be square root 3 over 2. This one is very similar to what we're working with now. I'm going to try the double angle formulas on this one. So cosine of 2x, which is your double angle, plus a cosine x. So what I'm thinking is if we replace this with something over here with a double angle, we can maybe simplify it or factor it. Okay, so what is strange here is that there are 3 of them, so we get to pick one of them to replace it with. Since I already have a cosine, I'm going to pick one of these to replace it with. I'm not going to pick this one because there's a cosine and a sine. That just makes it more difficult. I might pick this one, and I'm definitely not picking this one because there's a sine. So let's go with this one because there's just a cosine. I'm going to change everything to an x because there's an x there. So I'm replacing this with 2 cosine squared x minus 1, and then plus cosine x, and that equals 0. Okay, I'm just going to rearrange this. So let's see, let's put our squared first. So that would be 2 cosine squared x. Put my cosine next, and then minus 1. All right, this looks like maybe something that we could factor. How about we change everything to just a plain Jane x? 2x squared plus x and minus 1. Okay, so you can use the box or you can group, but make sure that you can do this. This is way, way, way important that you know how to factor this, okay? This factors to 2x minus 1 and x plus 1. And again, you need to practice this. It's super important. I'm going to set each of these equal to 0. 2x minus 1 equals 0. So x equals 1. X plus 1 equals 0. So x equals -1. I'm going to go ahead and replace my x back to what I originally replaced it with. So x, I replaced it with a cosine. Same thing here. Okay, we need to figure out where cosine is going to be. Whoops, that is not 1. That is 1/2. Okay, I need to figure out where cosine is going to be 1/2. So you would draw your triangles. So that would be 1 and 2. And since we are in radians, that's going to give me pi over 3. And it's also going to be positive down here. So that's going to be 5 pi over 3. Okay, for this one, you cannot draw a triangle. So I'm going to use my ordered pairs. So wherever cosine is -1, looks like this is the only place. So x is going to be equal to pi. Okay, now I want you to look at the half sheet. And if you don't have a calculator, you need to get one right now. So pause this and get up and get a calculator. Okay, honestly, this is pretty self-explanatory. I'm going to show the graphs and give you the answers. The main thing that you need to make sure to do is read this. Explains it right here. This right here says depends on mode and depends on mode. You know your mode by this. So these two problems are going to be done in degree. So if you're in degree, you're going to use 360 and 90. If you're in radians, you're going to be using the 2 pi and the pi over 2. But these things right here are what you need to change. If you don't change those and set them up, your equation or your graph is going to look crazy, crazy, crazy. Okay, so you need to take a minute and you need to graph and make sure you can do this. It's super important. You need to follow your steps, make sure you can graph this, and then see where it crosses, your line crosses your graph. Number 4 tells you how to find the intersection. This is a second. It doesn't read it for some reason. It says once graphed, use your second, calculate, and your number 5. That's your intersection key. To find these 2 points. So you're finding this point and this point. So that means that you're going to have x equals and x equals. Always round to 3 decimal places. So after you find those, make sure that you get the right answer. Okay, the second graph is going to look exactly the same because it's sine. So unfortunately, these have not gone away. Okay, this graph or this line goes up here. Again, you have 2 points of intersection. So that means that you're going to have 2 answers. If you can't find those intersection points, you've got to try. This is important right here to read this.